Hello friends, welcome to your channel PhiLab. Learn, analyze and build physics concept. Channel dedicated for understanding physics at +2 level. Thanks to all of you for browsing into this channel. Kindly subscribe to this channel if you haven't done up till now. And don't forget to hit the bell icon to get notified whenever I post a new video or solution from Newton Physics textbooks. Hello friends, today we are going to discuss about capacitance of a partially filled capacitor. So here we have got a parallel plate capacitor of plate area A. The distance between the two plates is taken to be D, and in between the two plates we insert a dielectric of thickness T. So we are inserting a dielectric of thickness T of dielectric constant K. So here is a capacitor. So it's partially filled with a dielectric of dielectric constant K and thickness T. Definitely T is very less than D. Now, in order to solve such a problem, what I would suggest that since this dielectric T is shown somewhere in between, what I can do, I can replace the same with another diagram in which I can place the dielectric somewhere. Instead of in between, I am placing this dielectric very close to the plate 1. So the dielectric is now placed very close to the plate, left plate. The same dielectric, same thickness T, but what I have done, I have placed it very close to the left plate. Now what I am doing, I am drawing an imaginary line to make that separation. Now you can see the line that I have drawn with a green pen to show that imaginary separation. Now the same problem which was with the dielectric T in between can be seen now as two capacitor, one completely filled with some sort of dielectric. So here you can see this capacitor is completely filled with some sort of a dielectric of dielectric constant K and thickness T, and another capacitor with air as a dielectric. So the problem now resolved to simple: two capacitors connected in series, one with completely filled dielectric. So the capacitance of this particular capacitor will be having the dielectric in between as K epsilon naught A upon T, and the capacitor of this having air as a dielectric will be C2 is equals to epsilon naught A by D minus T. Now if you see, these two capacitors are connected side by side or in series with each other. So these two capacitors are connected in series with each other. So the net capacitance of these two capacitors will be the series combo of C1 and C2. So what I can do now, I can find 1 upon C net as sum of 1 upon C1 plus 1 upon C2, where 1 upon C1 is nothing but T upon K epsilon naught A, whereas 1 upon C2 will be nothing but D minus T upon epsilon naught A. So you can take 1 upon epsilon naught common and you will get T by K plus D minus T, and this is 1 upon C net, or C net then will be equal to epsilon naught A upon T by K plus D minus T. So this is an easy way to derive the capacitance of a partially filled capacitor. Hoping guys you all must have enjoyed learning with this video. Please share this video with your friends and classmates and add in your comments which topics you want me to do for you, or any specific numerical problems you want me to solve for you. Thank you and enjoy learning.